All right, let's get back to work here. All right, anyway, so watch here. I don't know, I'm not too sure why this happened, right? Right, watch here. So from your box and whisker, you can figure out the shape of your distribution. All right? You can figure out the shape. So if a shape looks like this, it's called a symmetrical distribution. Don't use the word normal, right? Use the word symmetrical. Symmetrical means that from your highest to your lowest value, everything distributed equally. Right? So if your box and whisker looks like this, that is called a symmetrical distribution. If your box and whisker looks like this, it's called positiveness cubed. What that means is that you'll recognize that this tail is longer than this tail. You'll see that? And your cube 2 is far away from your cube 3. Everybody okay with that? So whenever your box and whisker looks like this, that's called positively skewed. Whenever your box and whisker looks the other way around, that is called negatively skewed. Right? So you'll recognize that the distance here is much larger. Right? But I want you to draw it with, don't draw this one, right? I want you to draw it with the thing on top. Right. Draw this one, please. Right, draw three. Left skewed, right skewed, symmetrical. Or, or the next name could be negatively skewed and positively skewed, right? Left is negative, right is positively skewed. So it's just like that with the box and whisker underneath. Oh yeah. Hey, 50 the up outside, huh? I up, do it quick. You're seeing this skewness right here. The one in the middle is symmetrical. Symmetric. I'll just do all the one, but I'll just put on the road. Right, this is something that we had to finish from last class. Today and next class, the focus is really problem. You're gonna get some easy and some very hard. Right, and then we take a look at a few examples and you'll tell me what type of skewness it is. I think you made it draw one in class. What? I'm box and whisker, last day. One or two. One or two. Right. So it tell me the skewness on the ones that you did. What? Skewness. Here the box and whisker shape. Finish. Look back at it, look back at it to that big tube, please. But check again example two. Right, we just want to know if it's left skewed, symmetrical, or right skewed. Now done? Right, I don't have the first example, right? But how the first example look? Symmetrical, left skewed or right skewed? Look back at the first one that we drew. Yeah, here's the first thing it is do. Check and see if Q2 in the middle of Q1 and Q3. Was it? It was in the middle? Which tail was longer, the left tail or the right tail? Or they looking equal? Much longer? Was much?
No, point one.
About a little bit, right? Right. So if I'm not mistaken, the first example was what? Symmetrical. Right? So write that down underneath it. Under the box and whisker, right, was symmetric. I think the second example was Q. Okay. Look at the second example and tell me how it looks. Alright, ready? Right. Let's check out a few examples from here, right? I want to show you our next way to figure out skewness without box and whisker. We can use stem and leaves. I'm moving this, right? How about a mouth? Right. Right. Take a look at this here, right? Tell me what you all think. Sometimes we don't need to get a box and whisker, right? Sometimes what we could do is we could look at this stem and leaf. So look at this example here and tell me what you all think. Hello? What do you think? We're looking outside. Right. Look at this here. We do not have to do a box and whisker to figure out the shape. Anybody can watch this and guess the shape? No. Right? Yes, yes. Because watch this here. We could do something like this. See that there? That's the beauty of the box and whisker. It shows you the shape of the distribution as well. Right? So how that looking? Symmetrical. Right? That looks symmetrical. So after you do box and whisker, more than likely you're going to get something symmetrical. Let's go again. Tell me what you think about this one again. What do you think about this one? Wait, hold on. What do you think about this one here? Left skewed, right? So you've seen it here, then it come up here and a short piece on that side. So the left side is a little bit longer, right? So this will be left skewed. Very good. Of course, the box and whisker will give you a more accurate answer, right? There are two things you have to look at: the tail and how far Q2 is from Q3 or Q1. That's okay? What about this one here? How that looking? How that looking? Right, skewed, right? Or positively skewed. So you're seeing the bob on this side and the straight part on the next side. You're looking it up? Yeah? Alright, now for the exciting stuff, probability. Oh wait, no, I should probably give you one more to do. That's a good idea. But you'll work out the shape already. Alright, to do me a favor. You don't have to do the box and whisker. I mean, you don't have to do the stem and leaf. They give it to you already. Can you prove that? Can you do the box and whisker and do a box and whisker quick and tell me what type of distribution it is? You know what you're supposed to get, right? You know what you're supposed to get. Please, your box and whisker have to be the scale. You use a ruler and draw like a 10 centimeter line, right? What's the smallest value here? And largest value, right? So do a box and whisker for me, and use a scale from 0 to 50. You have to use a ruler, yeah? Otherwise the box and whisker cannot give you the shape. Do this one already? See what the box and whisker we did?
Yeah.
And right, so use the box and whisker and see if it's positive. Huh? Box and whisker less you.
Yes.
You sure it's the same one?
Yeah, it is.
How would less
Oh,
you?
no, right. Alright.
It right skew, right?
Yeah.
Okay, okay. Alright, good night, 12. Be done there. Yep, a little go. Yep, a little. Right, head of probability. Probability time. Right? This is where this is the hard part, right? Probability. Yeah, pull up. I get some questions for you. Alright, so head of probability. So you have discussion.
What are you doing? I don't know what's in the key. Don't start this one there.
Right, so let's take a look at this. The probability of any event E is what? Probability of any event E is the number in E. Look, Kiara in the two now. Oh, look what she now. Kiara not watching. the number in A over the number in sample space. Right? So the probability of any event is the number in the event A divided by the number in the sample space. Right? So before we jump into anything, we should understand that all probability lies between what? Huh? Oh, I thought it 2 and 1. Right? All probability lies between 0 and 1. What does the probability of 0 mean? Never happen, right? What's the probability of 1 mean? It will always happen. Right? So we need to remember that. If we get a probability at negative, you do something wrong. If we get a probability more than 1, you do something wrong. Right? Right? So all probability lies between 0 and 1. Before we start calculating probability, we need to be able to generate sample space diagram. Right? We need to be able to generate sample space diagram. Right? These diagrams gives us all the possibilities. Right? These diagrams, what they do is they give all possible outcomes. They give all possible outcomes. All right? So I want to show you how to do possibility space diagram, right? Let's copy that down and let's try one here. All right. We do this recently. And do the whole thing or just review on it? And did the whole probability? That was all the probability. I did 3 diagrams as well.
Yeah.
Second thing. I know I was reviewing it, but I don't know if I. All right. Let me just do over this part here. Forget this here then. Forget the possibility space diagram. I'm going to redo the probability and then we'll focus on 3 diagrams. I don't think I did 3 diagrams. All right. So what's here? Everybody watch here then. So this is probability, right? And now if we have 2 events, so I'm just reminding you, right? If we have 2 events, then the probability of A or B happening, this is called O, is equal to the probability of A plus the probability of B minus the probability of A and B. This symbol is AND. Right? So I may have given it this already, but I still want to just go over something. Here, the probability of A and B is equal to 0. If this happens, then it is said to be mutually exclusive. Right? If the intersect is 0. And then, if A is dependent on B, then we have this conditional probability here. A given that B has occurred. All right. So this is called conditional probability, and we're going to spend some time on this today. Right? So we'll focus on conditional probability. I think when I was reviewing, I didn't do conditional on 3 diagrams. But I did 3 diagrams. So I had to review conditional. All right. So let's focus on conditional probability. Right? Conditional probability is when one event affects another. All right? Copy it down and let's reach it together. Copy that down. Alright, everybody watch here now. After effects. I try my best to write on this so that's it. I'd say improve on that. Alright, so watch here all here. Watch here now writing. Just take a look here for a minute. So we want to focus on conditional probability today. Right? Conditional probabilities when one event affects the other. Right? So for example, for it to flood, what must happen? Rain must fall, right? So flooding is affected by rain. Right? So here we want to learn about how to find those probabilities. So when one event affects the other, then we use conditional probability. Here we have conditional probability, and the way we read it is this: the probability of A given that B has already occurred. That's okay? So it's the probability of A given that B has occurred. In order for you to find this probability, what we need is the probability of A and B happening. And then we divide that over the probability of B happening. Are you okay with that? So this probability of A and B is dependent on, A given B is dependent on A and B happening and probability P. That's okay? Right? And of course, if we rearrange this, we will see that the probability of A and B is equal to the probability of A given B by the probability of B. Anybody could tell me what's the probability of B given A? What will be the probability of B given A happened already? What will that be? Look at this formula. It'll be the probability of, well, A and B. It don't matter to put in B first, all over the probability of A. Right? So this is the probability of A and B all over the probability of B. What we need now is we need to find a way to put this on a Venn diagram. Sorry, on a diagram. Right? So the diagram that we're going to use are tree diagrams. Right, so we're going to explain tree diagrams by doing a little experiment. And if somebody come up and maybe
Yeah. No.
yeah. Very easy, clear. I have copy it down first and then you'll come up. We got a little bag for this one. Yeah, our what?
Oh, yes.
No. Alright, so we got to see that.
So you.
All in had to yeah, fine, right? Move on. What we call it, like
What I guess. What is. I don't this. Why you ever figure out?
right? So we're gonna do a little we're gonna do a small experiment here and show you conditional probability, right? I'm gonna explain it so you know what we're doing. How about markers we have here? Right, how many markers we have? Five markers in total. So what we're gonna do, we're gonna check the probability of choosing two markers. Right? Without replacement. Without replacement means when you take one, how much you have left? 4. Take the next one, how much you have left? 3. So we are going to do a tree diagram. So the tree diagram, we're gonna take a look at choosing two markers. So this is to choose the first marker. This is to choose the second marker. That's okay. We're gonna take a look at how to work out the probabilities for all. All right. So how many options we have here? How many options we have? The colors. No colors. Two colors, right? We have blue or black, right? So we could choose a blue marker or we could choose a black marker. Are you okay with that? After we choose a blue marker, so we choose a blue marker. How many options we have? Colors. Still black and blue, right? So if you choose a blue marker, I could still get a blue marker or I could get a black marker. Correct? So you see how a tree diagram works? If I choose a black marker, how many options I have still? 2, right? So I can choose a blue or black again. So I could choose a blue or I could choose a black. So a tree diagram tells us what? I could choose 2 blues. I could choose a blue and a black. I could choose a black and then a black and then a black. That's okay? So what Kalia gonna do now, she's going to help us. So Kalia is going to help us put some numbers in it now. Some actual probability. All right. Come now. You can watch it if you don't like it, go and post it. Right, so what we're gonna do, what we're gonna do is the same thing. You're gonna select a blue first, and then you're gonna rewrite the probability. Right? So the first one is what? First one, if you choose a blue, the probability 2 out of 5. Right? And a black is how much? Right, and then we will just, you come here now, you remove a blue for the probability, then a blue. And a black. Right? And now suppose we choose a black first, for the probability again a blue. Right? And probably no, but leave with the 2 out of 5 and black. That's what I'm going to ask.
Okay.
Right? Ready? Ready? Right? So we're going to try to complete this tree diagram. We have to select 2 markers, right? And the options we have here are black and blue. Right? So I want you to complete the probabilities for all the branches. So firstly, your first option is select a blue. What's the probability?
Okay, take a blue.
Yeah, take out the blue and write the probability. Nice. Let's continue. So imagine 1 blue is gone, right? 1 blue gone. What's the probability of selecting the next blue? Right, the answer? Nice. What's the probability of, if you choose a blue the first time, getting a black?
Choose a blue first time, then a black.
Getting a black, yeah.
Oh.
Very good. Right? Now, let's go back again. Suppose you chose a black the first time. What's the probability of getting a black? Very good, because you have 3 out of 5. Now a black gone. A black gone. You want the probability of choosing a blue. Yeah, use the blue now. You have 2 blues out of 4. Very good. And now if you wanted to choose a black. Very good. Nice. That's a completed tree diagram. Very good. How long is it?
A minute. No, I don't want to know why I get upset.
Right? But there is something also very important, right? These little dots here called nodes. Right? Anybody recognize what is happening from each node? Very good. They always sum to 1. So if you had 2/5, you do matter figure it, work it out. You can just minus, here's 3/5. Here's a quarter. So definitely here will also be what? 3/4. If here's 2/4, here will also be what? 2/4. All right? Copy it down now. Right, so I just write in some notation here, right? So the probability of blue the first time here is equal to probability of blue the second time. Well, yeah. How can I write this as a notation, as a probability notation? It's probability of blue the second time, given that you had blue the excellent. Right? So I want you to finish out the other 5 there, the other 5. Right? Use the notation. Right? Use B for, oh sure. B for blue and L for black. I don't know. What will you use for black?
Yes.
Huh?
Yeah. I use it.
So we will use B for blue. Or we can use for black.
Yeah. Oh.
No. B1 means they choose the first marker. B2 means second marker. What do you use for black?
Yeah.
BL?
Yeah.
A? All right. A. A for black. Go ahead. Yeah, can make that clear. Sorry, sir. Yeah. How are you doing? I know what's up. Yeah, I'll edit stuff out. Right? So that's the way we represent conditional probability. Draw a diagram and add in all these things, summer, please. And I want to challenge you from this diagram, find 3 things, summer. Right, complete that diagram and let's take a look and find the 3. Huh? Did I get it already? Right, so there are 3 little things I want to find from that diagram, right? If it could, use a black and a blue, right? Huh? No, just do like declare, do like use that.
Yes.
Right, finish up the labeling, please. This is the probability of black the first time. This is the probability of black. Your first black, and it's your first black given that you had a blue the first time. Actually, I don't want to mix it up. I should put 2 here. Right, this one here. How to label this one here?
Fine. H1, D1, D1.
No, it's the probability of getting a black the second time that you have a blue the first time.
Given.
Given that here. How to write this one here? How to write this one here? Probability of what? Probability of getting a blue the second time given that you had a black the first time. Right? What's this last one here? What's this last one here? Probability of a what? Probability of black the second time given that you had black the first time. Right? If you do like this, you can actually write in words, right? If you want. So I have 3 things here I want to find out. Right? Let's go with Vishish. What's the probability of getting 2 blue markers? Hello, watching here? Watch first now. Right? Follow it down, write it down after. So you want to get the probability of 2 blue markers. Probability had to be a fraction between 0 and 1. How we getting the probability of 2 blue markers? So, which of these branches here 2 blue? Here and here. So, well, what do you do with 2 and a quarter? Multiply that. Whenever you go along a branch, you multiply. So you're getting a blue here and a blue here. Everybody okay with that? So you're getting a blue here and a blue here. So you multiply. So part 1. Right? So the first one, I asked for 2 blue. So you get a blue the first time and a blue the second time. So that will be 2/5 multiplied by 1/4. So I got 2 1/20 or 1/10, right? Next one. Pandina, next one. I want you to get different colors. Different colors mean what? Blue and a black and a what? Sorry. A blue and a black or a black and a blue. All right, enough. So probability of a blue and a black. That's okay? Or, right? You recognize what I'm doing when I use or. Or means what? Or, every time you use or, that's add. Every time you use and, that's multiply. Okay? So a blue and a blue, I multiply. This or this, I'm going to add them. Right? So I got a black the first time together with a blue the second time. So how do I get this? A blue and a black. A blue and a black. So that would be 2/5 multiplied by 3/4. How do I get this one here? How do I get this one? A black and a blue. 3/5 multiplied by 2/4. So when you add that up, that's over 20. That's 6 and that's 12, right? You okay with that? Do the last one for part 3, and then let's do a past paper. Okay. Part 3 is the same colors.
No way if you use specific.
Right, yeah, two black, same colors all here. Same colors, Dominic. Same colors, what to do? They must be the same colors. Right, so it will be the probability of B1 and B2 plus or multiply. Plus the probability of what? A1 and A2. Tell me right now how to work it out. Yeah, 2/5 by is 2 I must sit down in front. And a quarter. And next one is what? 3/5 and 2/4. Nice. So that is what? 8 and 20. You okay with that? So if you do your Venn diagram properly, sorry, I keep saying Venn diagram. If you do your tree diagram properly, right? It will all your values should work out nicely. Right? As oh wait, I call it Kiara. I mix up all the names. Akira. Sorry. And yours is Kiara. Sorry, I mixed it up. So Kiara was saying, right? Kiara was saying instead of working out this, we could just minus this from 1. And you'll get the same thing. Right? Which is correct. Right? Which is correct. If you add up these two, you get 1. So I'm going to show you into that tree diagram here. Do this, please. Right, let me see if online will give us anything. This
What? Let's say it. Eu assisto agora na escola, ah? So eu vou dizer, mas escola skip school, vou na escola só para escola. You skip school. You went to Venezuela. Teacher, I come here. Where was it nice? When you was in school.
Like in 1 day, you do that.
In 1 day.
Right, this is 2013, number 7. Try that, please. They give you the shape already, right? Okay.
That movie is what it is. Like movie is the right movie like when I heard that way, you put it on your head, that's the same. That's why I remember your assumption is that. There. You don't know. There. Sit there. Why you put it in? You sound off. You don't know. You malo what they ask. Yeah. Really not. I'm not gonna remove it. What out? Do you want to? Something. But are you okay? Nothing never for expenses. But I don't have this approach. Yes, no, look, whatever. Hoy día no sé. Yeah. Luôn farm. What kind? Yeah. Yes, yeah. I see said one husband, it's one more plan. Yeah, I don't understand. But I was I was yes. And it's what I'm doing. And it will be a time. Yes. Non c'è da arrivo solo davanti, eh? I don't follow me.
I had one for everybody.
Yeah.
What? Yes, she does. I think I got to. She is a was no, that's some the other is some part that's this Papa, that's some yeah, no, that's some. Wait, now pala na sa ika ba? Hindi mo tapos quickly. No, everybody was happy. Sometimes when I visit people, it look like it. But you got that. Alam sa start of term well pa siya the first time I got last week. Yeah, when I see it, what she saying?
Alright, done. I gotta take a quick. Alright, ready? Alright, ready? Let's take a look at what going on here. No, I'm trying to do it.
You're doing it now, right?
Alright. Y'all got through with it? Hopefully. Let's see. So of the persons buying petrol at gas station, 40% are females, so we automatically know that 60% are males. Right? Of the females, 30% pay cash, So of the females, 30% pay cash, so here will be 0.3, and here will be 0.7. Of the males, 65% pay cash, so the other method will be 0.35. What's the, everybody okay with that? What is the probability that the consumer pays for petrol with cash? Right? So you have to look and see, okay, well, the person wants to work out cash. So who are the people that can pay cash? Female. So a female paying cash will be 0.4 multiplied by 0.3. That's here, right? But okay with that? And then we could have a male. So I put in or. So or means add. Male is 0.6 and cash is 0.65. How much is that? What? 0.5. So the probability of cash is 0.51. All right, last one. Determine which is more likely to happen. Consumer is a female, so I wanted to write it here. But right, customer is female. Customer is female, given that she paid with cash. So it looks like that, F/C. And the formula is what? Probability of F and C all over the probability of C. How do we get female and cash? We work out that already. That was 0.4 by 0.3. And cash is what? To work it out, 0.51. We worked out cash here. Right? Remember we worked out cash a while ago. Cash was 0.51. Right, but it don't matter. They ask for cash. So cash has to do with both male and female. So they want to know who paid cash. That's it, both male and female. So multiply that, you'll get 0.121. How much that simplifies, sir? Anybody got that? 1251?
Yeah.
And you can simplify a little bit? No? Over 17, yeah. That is event T. In case you made a mistake, do over event B from another place. Probability of how to write it up here. How to write B. A male customer does not pay with cash. How would I write that? It will be M for male. You show it flash. Or is it intersect? Intersect. Right? It's a male customer does not pay. Right? It didn't say given that doesn't pay. So you're looking for the keyword given that. So a male customer does not pay with cash. So you can put other here. So that will be 0.6 multiplied by 0.35. How much is that? 0.6 multiplied by 0.35. 21? Sure, right? Multiplied, right? All right, nice. 0.21. So which is more likely? 0.21 or wait, what is 4 divided by 17? What is 4 divided by 17? What is 4 divided by 17? So which is more likely? A female using cash, right? Let's go again. Let's try next one. Anybody writing? Let's try one with 3 events here. 2018 number 8. So instead of 2 branches, it has 3 branches. That's the one with insecticides there. If you're not seeing, go to the topic by topics and go to 2018 number 8. That's way down in the end.
Like, why did you do
Try that please. 2018 number 8. It's way down in the end. Go to the topic by topic and you'll see it. Oh, you have joy diagram. Joy diagram. So you have how many from the first node? A, B, or C, right? So you have 3 from the first node and how much from the second node? From the first node is A, B, C. And when you reach the second little node there, how many branches? No. What will happen to insecticide E? It works or it doesn't work, right? How many options is that? Two, right? So watch, it'll look like this. Insecticide E, insecticide B, insecticide C. Right? And then what would happen? Either insecticide A is successful or not successful. Successful, not successful. So your diagram might look something like that. Right? Construct it, answer the last part, and then I will do it on the board. Last one, yeah. So you'll come on the board and do it. I like how you bring that up.
So sorry. Bye. Hey, you learn the Yes, they are. Just one.
Oh, yeah, joy diagram. Vishishu, come on, fill this one out for us. I'll just drop the little tree for you and you will fill it in, right? Or you will do everything? You will do everything?
We just see you everything, so I am also. And say what you. No, sit down. That one I think was before. Think I got everything. Thanks. I do. Well, I can see that. I think you put it. Give you put it.
I have book out all. Right, they want the probability of not successful.
You were.
Is she ready?
Think so.
Someone put in your values, huh?
You like me to send one something?
You want to take the other. Probability, you check it and make sure it's correct, Audio. Probability, can write 40. That's not probability. Yes, custom, that's so good. 0.4, 0.3, or 0.25.
251.
Right? Always make sure it adds up to 1, right? Right, you 4 good now, looking like 4 something. What's that?
Sorry, different what we're teaching.
Right, next one. Successful on E. Successful on top. That correct? Successful is 0.8 for E?
Yeah.
Okay. 0.65. What's the next one?
I don't.
Chinese real rob you boy. When they come back one turn, they'll take all the money.
Yeah. After I rolled them accidentally. No, that's the problem. I really good. Better be felt. It is. Straight like it. And that's the control. One class. Wait, I think.
That correct? And now they want the probability of not successful. Show them how to do that. So your tree diagram looking good? Probability of not successful. Unsuccessful.
Hospital. I feel like hospital.
I can pass.
Them are the see.
They're looking for all the times it's not successful, right? He said 0.4 by 0.2. Nice. That is when E not successful. He probably gonna write when B not successful now. 0.25. We get that from. Guys, you all on good up? Take that. Nice. And last one. 0.35 by 0.5 or 0.05. So I have that.
0.05.
Right, bad. 0.57. What I got up? Check it back and see. Oh, yeah, don't calculate now, right? Hold together.
What's there, right? You know, Sarah, the phone focus.
Yes.
I give she my advance, my cash should have she advance exam. I know what she said, so I don't get back.
What's up? Check it. I don't have my calculator, so check it back now. 0.185. Anybody get out with the calculator?
Yeah. 185.
0.185. Online, anybody get that?
So the calculator.
Oh, you have no calculator using your phone. Check it back and see. Do it. Do it one by one.
Oh, yeah.
Okay. All right, so that's 3 diagrams. Can we squeeze in one more?
Ah,
Oh,
So
you gotta move fast.
so you need your promise.
I did.
I go.
All right, all right. That's it there. Right, what we're doing more on this, more probability. And we have a multiple choice to do on Friday as well. Wait, what it is? Yeah, Friday.